Here's the soon-to-be Valentine supercell at Kadoka, South Dakota. Remember, it fired up the Black Hills, so it's moved a little ways already to be at Kadoka. You see the horseshoe shape of the updraft base and the RFD notch. The sinking dry air wraps around a little bit and cuts forward. Just shapes the base. The flanking line is out here. Storms shorter updrafts moving upwards and then going up and dumping their precip to the north. And there wasn't a whole lot of a hook echo on the radar at this time. And the RFD notch is pretty dry looking, as you can see. There wasn't much precip wrapping around to make a hook echo right now. That'll change. Anyway, just to give you an idea. And the problem right now is probably maybe not enough low-level shear yet. And the base is still pretty high. It tried to get a lowering and even would wrap it off, but it was just so stagnant it wasn't hardly rotating back there. And a while later, here's the supercell at near Mission, South Dakota. So it's getting closer to the Nebraska border. You can see it exploded big time around here. It just went nuts. See, the base is still pretty high. It tries to lower, but what you'll notice is this big round updraft. You can see the plumes now on this in the kind of inflow beaver tail area band. All the heavy precips to the north and then to the east of me. I'm looking west down this highway. You can see the RFD notch, the curl. The RFD notch has now got a lot of rain in it. So you remember on the radar as it neared the Nebraska border, it had that better looking hook echo. So that's what's happening. The updraft spinning and it's pulling in rain behind and coming down. And it got really full of rain. And remember, as the air is kind of dry or dryish, all that rain is making rain-cooled air, and it kind of makes that storm go into an HP outflow-driven type mode, and it's hard to get it back out of that mode once it's in that mode. Now here's the supercell after I moved ahead of it a little ways. I'm now just north of Valentine, Nebraska, just into South Dakota, looking northwest. See this long, low-level inflow band of moisture streaming into the storm. You see how it's round. You can barely see where the right side will be, and all that precip's over here. There's a nice hook echo on radar now. You can see the RFD in the middle, the horseshoe shape, is all full of rain. There's a big hook on there now. See the anvil's got the mattis bubbling out. Because you get all that upward motion that goes up above where the temperature inversion is aloft, where your air temperature starts rising. But that momentum carried all that convection up through there, and then it kind of comes back down, kind of billows outwards as mammatus. And what I'm going to do here is I'm going to overlay North Platte sounding just for kind of scale here. This isn't perfect because I can't stretch this exactly right, but basically, like, see where your temperatures, where your rising air temperature starts to be the same as the actual air temperature is up where your anvil level is going to be, and your moisture depths clear down here, pretty much probably around in here and below is your moisture depth, and then everything above there is all your cape in here, like your whole updraft height up to about 45,000 feet is right in there. So your top might bubble up higher than that and go above the anvil up into the 50,000 feet area. But anyway, that sort of might give you an idea with the sounding overlaid on an actual supercell. Close as I could get it, pretty much. I have two photos from the same spot here. I'm going to show you how it approaches and how it goes pretty much right down this boundary. And you remember on the satellite loop, or the satellite images, how the air just west of here and southwest was drier. This was like coming down the west edge of that deeper moisture Q field you could see on satellite. So anyway, and this is just a big long inflow band. It went way off to the left, to the southeast. The storm just goes right down it. And also you can see these bands coming in this way and this way and this way. Kind of get how that storm's spinning. As it rises, it's spinning. Anyway, here I'll show you the next frame. Kind of a cool little perspective here as it approaches. And watch how it goes right down that boundary. And now that it's gotten closer, it's also getting stronger and even lowering now a little bit. And now it's starting to get the better characteristics down low. Tail cloud going into lowering back where it should be. Plus, on a lot of supercells, you'll get that front part to cut off and try and tornado too. And there was a tornado report about in here, and this might be it, where it just gets cut and then the front part starts spinning up, and then that would rotate around, and then a new one would do that too if it was cyclical. You can almost see the dust underneath there in the little cone. But anyway, you can see how the base is sort of straight right here. It's a humongous storm that's very round, but the base is kind of straight. And if you notice, the base isn't super wide. This is more tall you're looking at, and it's just kind of skinny. It's almost more shelf-like. You can notice on storms like that, you're less likely to get a tornado, unless you can get a cut in there somewhere that kind of cuts in and wraps an area so it gets a little wider. But even this, you'll notice all this surging cold air underneath there. And it's gonna, if you had, because this goes way around off the screen rounded. If you had a tornado that wanted to form in here, it's going to be trying to get messed up by all the cold surging going this way. So you just got to watch that, because once it's got so much cold air going, it's hard to get anything wrapped up. But this thing's a beast of a supercell, even if it's very outflow dominant. These bands are flowing around into that mess. So you can see how that almost looks like a shelf just because of how straight up and down it is and how forced, but it's very round over the scale of the base, and it just goes clear around. It's got this lower mid-level inflow band that's curling around into the updraft area. But this thing was a beast. And notice the winds don't sound too bad because the road is north-south. I'm facing north. And the winds are out of the due east. Very, very strong. You'll notice in a clip coming up, when I actually pop my head above the car, you'll really hear that strong wind. Just an incredible supercell now. Too bad there's no roads to go east with it. Incredible. Oh, that's bad news there. That's like the core from hell in there. The core from hell. Wonder if Valentine still exists. Yeah, this thing's gonna turn into a little ball and roll straight south. This is one way a lot of tornadoes will start if they don't have too much outflow happening. The storm isn't too outflow dominant already. You remember that structure when I'm getting out here. This is the middle of the RFD cut into the storm. A lot of times that's where it'll lower and get an even sharper cut. It'll have all this going on, but then it'll get its own cut, and that'll continue to grow around as it rotates around, and then it really tries to produce a tornado. But as you can see on this storm, if that happens and this cuts in even further and wraps this lower as it's moving around, once it gets over to that interface where all that rain-cooled air is shoving south, it just can't wrap into that, so it can't tornado. But that's pretty much what would happen here. gonna have to go south. This thing's turned into a bowling ball, whatever that means. I don't think I want to play in that core. The big hole supercells round off to the left. Now watch this area in here, where this would be the area it would try and wrap up if it could do it. It'll start cutting in here and it'll grow and grow and grow, and it'll be trying to get nicely balanced and wrapped up. But watch the undercutting from all that cold air from the core driving south. You'll see how much it changes, where it's cutting in, but then this is winning. It just starts undercutting it, and by the next clip or segment where it jumps to, you'll see how much this is just totally undercut there and killed it. I really want to stick my head out the window now. Yeah, this thing needs to go straight south. Playing the hail, man. The window let up. The storm has now gone super crazy, obviously. This is just south of Valentine. It's going to be a little hard to explain it all here, but you'll see more on video. Supercell base, it's going from here, going almost over the highway, because this is a north-south highway, and then it's curling way back around here. So that's the supercell base. And your beaver tail would be over here, stretching east, and your heavy rain core would be up behind there, generating all this cold air. It's so much cold, crazy outflow air up there, and then your hook's also filled with crazy cold air and hail. But it's like you almost have so much happening, it's making its own front, and all this air scooting south, bumping up against the warm air, making all these clouds, even these really, really low clouds. And as the supercell's spinning violently, all this air is drawn west. You can watch this stuff just screaming west as it comes overhead. But I want to show you what the tornado warning with this storm was at this time. Well, first off, once it's so outflow dominant and it's got so much pushing like this, you can see how you can't really wrap around. It's all wrapped around, but there's so much pushing this way, it's like it's not going to be able to wrap in there very good. The only tornado that really happens here is like an inflow tornado, kind of on this sort of deal in a little while. Kind of just strong inflow, a little spin up happens, you get a little tornado. But the big one, it's harder to get once it's like this, unless it's clear back here wrapped in rain. But it doesn't have that look really. But there was a tornado reported in there around this time. But anyway, here's the tornado warning text. Well, I just want to note the last part of it. In addition to the tornado, this storm is capable of producing baseball-sized hail and destructive straight-line winds exceeding 100 miles an hour. You never see those together. It's hard enough to get baseball hail, and it's hard enough to get warnings with winds exceeding 100. I've never heard one with them together, baseball hail with over 100 mile an hour winds. Kind of flattening out. Oh my god, that's crazy to the south. Nice 3-inch hail indicators even south of me now. Look at this storm. Yeah, probably gonna want to go before this wall. Ooh, very fast. Here.
It's dark as hell up here.
A couple things to quickly mention here. The updraft base, that whole structure's like kind of south of me now, southwest. So some of the hail that's, hail ain't going to get blown out as far as rain generally, but of course the updraft's leaning for miles. But I'm getting some of that hail shot out of the updraft to land on me. And the beaver tail, the thing about a beaver tail that like this, the thing's almost on the ground. It's not real common to get one that crazy, that low. And the thing about any cloud or fog bank like that, it looks like a structure from far away, but as you get closer, you just lose all of it. Obviously, you end up in clouds. So it's kind of cool. You'd think you could just drive up to it and see something real cool, but you just kind of drive into fog and cloud. But anyway, think about all that low-level inflow from the southeast and east on this structure, and then think about all that rain-cooled air that's falling down out here, and that cold air surging south. It's kind of all bumping into each other, so they're kind of shoved back this way. You can see all this crazy flow along that beaver tail, or that interaction, that interface between the two air masses, just ripping this way. And I'm not sure if you'll be able to see this real well on TV or not, but watch these cloud tags if you can see them. They're moving this way so fast from the west, or from the east to the west. Just crazy speed.
Crazy speed on that. I should probably go south. Oh, that one hit me right in the top of the head. Oh, all right, that hurt. Oh, crap. Dude, look how fast those clouds are moving. It's 8:52 south of Valentine, going south now. That's crazy. I might go up the road and see what hail falls after this goes through. Sick.
You can notice a few things in this screen grab, this freeze frame. First of all, you can notice this area back here and this. Remember that shrinking hook? It's almost like you could see this as the shrinking hook, the base kind of getting smaller over here. That ain't very big. But then this is that part that was coming from the back, surging around. So you can really see that in this image and how low that beaver tail area is. But also to notice is the base of that storm was relatively high especially compared to the beaver tail, from all the cold air hitting the warm air. That just gives you your lowering, but the actual storm base was decently high. It wasn't crazy bad, but it wasn't real low exactly either, except for where you're getting outflow air hitting the warm air, causing the lower clouds. But anyway, I thought that's pretty cool. You can see that back part's about to come around, and that'll just make it even wrap up bigger and more. Okay, this base is pretty high, But regardless of that, it's still totally capable of producing a tornado. So it's kind of not real simple. But you got this much storm scale like forcing and low level inflow and just dynamics. You can get enough of a spin and it creates lowerings. That's clearly low enough, obviously. But it's just kind of interesting how high the normal base is. It's fairly high. And you can also think about that high base. Probably got a dry air in a layer up there. We had good surface dew points, but I'm sure there was some dry air working in the low levels out here on the western edge of that moisture. The storm could have been, going in and out of, or just getting some of it ingested. So it creates all that evaporational cooling when the rain falls into that and evaporates, probably helping cause so much of that, outflow push. Because you get microbursts when that happens. You can get really intense winds just from that evaporative cooling. Just imagine rain falling into it, evaporating, creating a bunch of cold air, and that just slamming to the ground. So with this storm, it's probably a mix of strong, sheer, good low-level moisture, but even that evaporative cooling is driving this thing. It's really driving the outflow air, which is slamming into the good lowest level air. It's just really dynamic. But you can see how low that beaver tail is. Hard to even call it beaver tail because it's so low. Because usually a beaver tail is, attached to your base, and a tail cloud would be attached to your wall cloud if you have one. But that's a beaver tail, just about on the ground. Kind of weird that there's almost two things arguing against each other. In one sense, there's a big clue that you're probably not going to get a substantial tornado out of this right now. It's not quite the separation you have up here, but the angledness down here and these clouds here. You can almost tell how there's just an insane low level push of cold air that's just shoving under everything. Just how this is leaning. The bottom of this beaver tail dealy is leaning towards the camera. The top's leaning out like a wedge. You can see how that'd be like a ramp. There's a wedge of cold air back there, and it's such an angle that it's just you don't see tornadoes when you see this. But then at the same time, just back here, it looks pretty prime. The tornado, the structure, because you'd have your biggest RFD pushing in behind here and cutting it around. But even the inflow right in front of there is where, because a lot of times when you see a tornado, you see this inflow pole on this side north of where it forms, and then the RFD comes in the back side, and it looks flat. And it's obviously really, really low. So it's kind of weird. I could totally see a tornado happening, but that would have probably been too much with this structure, because it's crazy to see this structure. Can you imagine a big tornado under there too? Anyway, that's a pretty big clue that you're probably not going to get a tornado, just that slantedness of that. Or if it was more upright, then maybe, but it's just so slanted. So you could imagine this slantedness going all the way back in here. Like if you take this slant, especially you can see it extending up here, this slant forward is the lower you get. If you imagine that backwards, you got the whole bottom of the storm is slanted forward. it's getting pushed south too much. Doesn't let it wrap up. Pretty much what happens too.
I cannot open my eyes. There's too much crap coming in here. Is there a tornado going on anywhere or what? This is the most messed up storm I've ever seen. I need to... I wish I could change the exposure. These trees are going to start ripping apart right by me. This is incredible. What it's doing in there. Crappy video quality for sure. It won't switch to freaking...
You don't see these terribly often, and they're worth pointing out. It might be hard to see on video as well, but up here there's a train of what's called Kelvin-Helmholtz waves, instability waves. They look like waves on an ocean. They'll go up and curl. You'll watch, they'll curl around there, but that's what they're called. You don't see them a whole lot. I think I've seen them on 2 other supercells on the base like that, but these were really moving. You could watch these curl and crash.
Slightly incredible. It's 9 o'clock now. My eyes are horribly full of dirt. The one I didn't snap.
Sometimes storm environments, storms can change really quickly. Whereas for the longest time now, this storm had just sat west of this highway as it moves south, just west of the highway. I was up in here in the notch, content shooting the storm and the lightning, trying to get lightning on stills. And then I noticed, but I kept blowing it off, the RFD surge, this whole RFD, the flanking line, you know, this whole wrapped up parts to the north. But I noticed it was getting closer and closer finally. But I was blowing it off, trying to get some last few shots in of some lightning up in that, near that beaver tail area in the core. So I kept blowing off. I kept thinking, oh, I got time to race south and get out of the way because it ain't moving very fast. Well, I didn't know, and I should have paid more attention to just how fast this RFD surge comes finally. You'll see it on radar a lot better. But once I turned south, I was like, oh, I'm not going to make it. And I get nailed by this thing. The video ends before there, but this thing just nails me with strong west winds, about blowing me off the highway. But I didn't want to stay back in there, because who knows what's buried back in there. So I kept going south, even though it was really hard to drive in. But anyway, that can catch you off guard sometimes. I'll show you the radar.
I'm sure this is going to be noisy as hell, but whatever. I need to go south very, very quickly. and I'm gonna get blitzed.
Now here's the radar earlier. After it went through Valentine, when it was just getting wrapped up, gonna go south down this highway. And I'll try and step it forward as slow as I can. But you'll notice how it replaces itself. The whole time it's staying, you know, west of this line, say. Now watch. It'll take over here, but it's still kind of west. Now it's really going to go west. See, it's still in that same spot. Now that thing come flying forward so hard, and I'm up in here trying to shoot the lightning that's happening in the core and along that beaver tail. And I was staying there as long as I could, trying to get more shots in, and I didn't notice just how fast that thing was come barreling across now. And it just nails me. Bam! I mean, it just flew over the highway, and I'm trying to drive south in that and stay out of the hook. I don't think anything was back in there at that time, but you never know, especially with that crazy of a hook beforehand.